This lesson is a review for a practice quiz for college algebra. Some of my very needy yet wonderful previous students have asked me to make a video for them. So I'm going to cover 10 problems that I believe are covered in the first unit of college algebra at our school. So if you are in one of my LSS Math 94 or Math 95 classes, please do not watch. This is a little more than what you are ready to work on, and I would prefer it if you did not get more confused. So again, this is for college algebra students only. Okay, so they're asking us to solve on number 1. So this is just solving equations. So the whole goal is to get our x by itself. Okay, so the very first thing that we always do is get rid of those parentheses. So the way we get rid of those parentheses is to distribute that number in front of those parentheses, which means to multiply. We're going to do it to that set and to this set. So 3 times x is 3x. 3 times negative 2 is negative 6. Bring down your plus 7x. Bring down that 1. Notice that this is a negative 2. So negative 2 times x is negative 2x. Negative 2 times 1/2. Let's do this over here. So what I've done is I have put that negative 2 over 1. Remember, when you work with fractions, you need to make everything a fraction just so you can see the numerator and denominator. So now I'm going to multiply my numerators and my denominators. So that gives me negative 2 over 2, which is, negative 1. So this gives me a negative 1 here. Again, we just multiplied that negative 2 times that positive 1/2. So after you get rid of your parentheses, so step 1 is going to be to get rid of those parentheses. Step 2 is going to be to combine. I'm going to put LT because I don't have much room. Combine like terms. So we do that on the left side and the right side. Now when I do teach my Math 94 students this material, I do make sure that I draw that line through that equal sign just to help them see. And if you do kind of want to look back at your notes, if you did take my Math 94 class, this is section 1.6 that we learned this in. Okay, so combine your like terms. 3x plus 7x is 10x. And then you bring down that negative 6. Then combine your like terms over here. Well, my like terms are a positive 1 and a negative 1. Well, when you combine those two terms together, you get 0. So that means we're just left with a negative 2x over here. So step 3, you get x's on one side. Okay? So we want to have all of our x's on one side or the other. Okay, so I always recommend that you move the smaller x because that keeps your x positive. So what I'm going to do, I'm going to look at my 10x and my negative 2x. Well, the number that's smallest is the negative 2x, so I'm going to add 2x to both sides. So 10x plus 2x is 12x. You bring down your minus 6. Now, it's not just blank on this side over here. When you combine negative 2x and a positive 2x, you get a 0. That is still a number. All right, so now we're going to solve. Hopefully you know what to do here. You work your addition and subtraction first. So you take care of your AS, addition and subtraction. And then the last step is going to be to take care of your multiplication and division. So we should add 6 to both sides to get rid of that subtraction. Those cancel, leaving you with 12x equals 6. And then you divide both sides by 12 to get x equals. Now, when you simplify 6 over 12, some of y'all might automatically say 2, but that's not correct. Remember, when you simplify, you divide the top number and the bottom number by a common factor. Well, that common number that goes into both of those is 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. So your answer would be x equals 1/2. Okay? Now let's move on to problem number 2. So on problem number 2, again, get rid of those parentheses first. So we have 3x minus 7 equals 3x minus 6, because 3 times negative 2 is negative 6. So now we get all of our x's on one side. So I'm going to subtract 3x from both sides. Now look what happens. Those 3x's cancel. Those 3x's cancel. So you're left with negative 7 equals negative 6. This is called a contradiction. A contradiction is whenever you have conflicting information, meaning what what is on this side is not the same as what is on this side. That's what a contradiction is. Whenever you get a contradiction, you're going to tell them that there are no solutions. Okay? There's nothing that you could have plugged in here for this x and this x to give you the same number on both sides. That means that this equation started off unbalanced. We're used to them always starting off balanced, like on problem number 1, where you get x equals a specific number. But that's not always the case. All right, so now let's look at number 3. So let's get rid of those parentheses first. So I have my 3m plus 3. And then 3 times m is 3m. 3 times 4 is 12. Bring down your minus 9. And now we're going to combine our like terms. There's no like terms on this side, but there are like terms over here. So I'm going to bring that 3m down. 12 minus 9 is 3. Now hopefully you notice something very special about this. You may notice that everything on this side of the equal sign is the exact same as everything on this side of the equal sign. If you didn't get that yet, well, you could subtract your 3m from both sides, and then you're really going to get it when you see that 3 equals 3. Okay? That is a true statement, and it is called an identity. Think about whenever you see identical twins, they look the same. So an identity is when you get one number equal to that same exact number. Whenever this happens, this means that you're going to have an infinite, don't judge me, number of solutions. That means, by saying that we have an infinite number of solutions, that means that whatever we plug in for this m and this m here, we're always going to get a number equals another number, okay? So it doesn't matter what we plug in, it's always going to be a solution. You're always going to find a solution. That's why it's an infinite number of those. Okay? All right. This is so much fun. So on problem number 4, oops, I didn't finish this one off. Sorry, guys. On problem number 4, we learned this, y'all, about how to stroke on me, but we did learn this. Again, this is also section 1.6. So this was at the very end of that section where you see all those nasty fractions. There are plenty of these examples on the study guide and on the homework that I gave you. If you would still need those assignments, I'm more than happy to give them to you if they've fallen off of your account. That way you can see more examples. So I always start this off by asking my students who likes fractions. Normally you guys tell me nobody, or there's that smart butt who likes to raise their hand and say, I do. So what we want to do is we want to get rid of those fractions. Well, the first thing we're going to do is we're going to make it easy for us to see. And I'm going to make that 4 a fraction by putting it at 4 over 1. Okay? I know the whole goal is to get rid of the fractions, but when you're doing this, it's going to be easier if you can see the numerator and denominator of everything. So to get rid of these denominators, we need to find a number that they all will go into. So between 2, 10, and 5, the number that they will all go into is the number 10. So I'm going to multiply everything that has a denominator by 10. Everything that has a denominator multiplied by 10. So 10 times 1 is 10 divided by 2. So that would give us 10 divided by 2, which is 5. Instead of having to do that process with every single fraction, there's a faster way we can do this. We could simplify first by saying that 2 goes into 10 5 times, that 10 goes into 10 1 time, well, 1 goes into 10 10 times, and then 5 goes into 10 2 times, and then multiplying what you have left. So 5 times 1 is 5. 1 times negative 3x is negative 3x. 10 times 4 is 40. 2 times 2x is 4x. Now hopefully you can do this problem. So there are no parentheses, there are no terms that you can combine. So now we're going to move all of our x's to one side. So I'm going to add 3x to both sides, which gives me 5 equals 40 plus 7x. I brought that 40 down, 4x plus 3x is 7x, and I brought the 5 down. So now I'm going to move everything on the other side away from the x, because my whole goal is to get this x by itself. Okay, so I'm going to subtract 40 from both sides, which gives me negative 35 equals 7x. I'm going to divide both sides by 7 to get negative 5 equals x. Okay. Now here's where the fun starts with absolute values. This is where my confidence level kind of went down a little bit because it's been a long time since I've dealt with absolute values. So when dealing with absolute values, you are always going to take your equation and rewrite it twice. Now the only difference is you completely copy it down exactly the way it is one time without the absolute value, okay? The second time you write it, you rewrite it with whatever your absolute value is opposite of that is. So since this is a positive 3, we're going to write a negative 3. And that's all we're doing here different, guys. So you're going to find 2 separate solutions. So you subtract 15 from both sides here to get 4x equals negative 12. Divided by 4, x equals negative 3. So that's one of your solutions. And then subtract 15 from both sides. 4x equals negative 18. Divide both sides by 4 to get x equals negative 9 over 2. That's another one of your solutions. So when solving the absolute value inequalities, you should get two answers because you're going to do the situation where one of them is positive and then where one of them is negative. Okay? You leave absolute value symbol alone. All right, inequalities. If you need a review on what we did with inequalities, that was section 1. So with this section, we are going to always try and keep the variable on the left side, okay? We do not want it on the right side, we want it on the left side. Okay, it makes it a little bit easier to graph. So I'm going to add 6w to both sides, which gives me 4w plus 6w is 10w. Bring down your minus 1 is less than or equal to 4. Now I add 1 to both sides to get 10w is less than or equal to 5. And then I divide both sides by 10 to get w 1/2. Okay, remember you're dividing both of those by 5, so that gives you a 1 in the numerator and a 2 in the denominator. So now one of the things they want us to do is to graph. I do not know what your teacher's rules are with graphing inequalities. I'm just going to use mine. So when I'm graphing inequalities, I tell you that you have to have 3 separate points or tick marks plotted on your number line. That's my first rule. Okay? So what I'm going to do is I'm going to put 1/2 in here. And the easiest way to do this is to put a 0 in the middle number and then put a negative 1/2 in the smallest number. Okay? So it's always easy to start off with a 0 in the middle. Whatever your number is, put it on whether it's the positive or negative side. If it's negative, put it over here. If it's positive, put over here. And then just do the opposite on the other side. Okay? So now it's less than or equal to. Remember, when I taught you that for less than or equal to or greater than or equal to, you're going to use a closed circle. And I said for less than or greater than, you were going to use an open circle. I don't think that they use this in the college algebra classrooms, so I'm going to teach you the other symbols as well. And we did write this in class, FYI, so these should be in your notes. So less than or equal to or greater than or equal to. They are going to use brackets. Notice how they are very boxy, okay? And if it helps you, notice that the equal to sign can be one of those boxy lines. That can be how you remember that. Sorry about that. And then for the less than or greater than, you're going to use parentheses, okay? All right, so it says that 1/2, which is the number we're working with, is W is less than or equal to 1/2. So that means that 1/2 is the biggest that it gets. So we put a bracket here, and we shade to the left. Remember that arrow trick only works when the W or the X or whatever variable you're using is on the left. So that tells us that we're going to shade this way. Now, if you were going to be shading to the right, then your bracket would be facing that way. Only if you were shading to the right. So your parentheses or brackets are going to face whichever way you're shading. Okay? Now they want us to write this in what's called interval notation. Okay. So interval notation is what you use. You're going to have something that's kind of like an ordered pair, okay? So I'm trying to think of the best way to explain this. I've never actually taught this in a classroom, so my words aren't exactly formed the way they normally are in class. So what we do is we always find the number that's all the way on the farthest right of your graph, okay? The number on the farthest right on our graph is 1/2. And if this was an infinity, meaning it kept going and going and going, if this was the way that we shaded, we would use parentheses. If it was just a less than or greater than, whichever one would fit here, and you used a parentheses here, you would use a parentheses to close it. But since this was a less than or equal to, that means that we're going to have to use a bracket. That lets people know when you're using interval notation that you are including that 1/2 in that set. Okay? Then we find the number that's furthest to the left. You might say it's -1/2, but it's not. Our numbers keep going on and on forever. That's what shading that arrow means. So that means that our graph is going to go all the way to -infinity. You write that sideways 8 there, okay? -infinity. So remember, when we use an infinity, we're going to close it with a parentheses. Okay, so that is what is called interval notation, and I highly recommend doing it in this order. First, go ahead and solve the inequality and get whatever variable it is by itself. Then I want you to graph the inequality, then write it in interval notation. If you can look at the graph, that's going to be a lot easier than looking at this inequality answer that you got. That's a little more confusing. Okay? All right. So next, let's look at number 7. All right, guys, we did not go over these in Math 94 or Math 95. We did not learn these. So when you're looking at problem number 7, notice how there are 2 inequality signs. Holy moly. Okay? But you've only got one x, and your x is going to be in that center right here. Well, what you're going to do is think about it as this is the parent, and you've got a child on this side and a child on this side. Well, you know, if you are not fair and you give one child something and you don't give the other child something, then all hell will break loose. So what you're going to want to do is every time you do something to get this x by itself in the middle, you've got to do it to this side and to this side. So imagine that we have 3x minus 6. We're trying to get this x by itself. Just imagine that this is all that we have. Okay? So if this is all that we have, then we would add 6 to both sides. Okay, well, we have this side as well, so we're going to add 6 here. We're going to add 6 here. And we're also going to add 6 here. Okay? So now you add everything. So -36 plus 6 is -30. Bring down your inequality sign and your 3x. Other inequality sign because -6 plus 6 cancels. And then 12 plus 6 is 18. Okay? So now, again, imagine that this is all we have. You would tell me to divide both sides by 3. So I've got to do it to everything. So I'm going to divide this side by 3. And I'm going to divide this side by 3. Okay, what you do to the middle, you got to do to everything. So -30 divided by 3 is -10. Those 3's cancel, leaving you with x. 18 divided by 3 is 6. All right. Now I have seen it where some teachers will just let you do the 0 in the middle, a 6 on the right, and a -10 on the left. I have seen it where teachers let you do that. But that is not mathematically correct where my thinking goes, because if you put the 0 here and the -6, or the +6 here and the -10 over here, Well, then you're saying that 6 is the same number of spaces from 0 as negative 10, which isn't the case. So I'm just going to count in twos. So negative 10, negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, 10, 12. Okay. So you can count in whatever intervals you want to count in. That's how we were able to do that negative 1/2 and 1/2 in that earlier problem on problem number 6. So now we have a negative 10 and a positive 6. So what they're telling you is that x lies somewhere in between negative 10 and 6. Okay, well, negative 10 is here. I'm just going to put this little star here just so we can see it. And then positive 6 is here. So it's saying x lies in between here. Well, on negative 10 is a less than symbol. Okay, so that means that we're going to use a parentheses. And then 6 is a less than or equal to. So we're going to use the bracket. If your teacher lets you use the circles, this would be an open circle and this would be a closed circle. Okay? And so since it says that x is in between these two, oops, sorry about all these extra little dots, guys. It says x is in between those two numbers. So we're going to shade in between. Okay? Okay, so now interval notation. I love it when they give us problems like this because this is even easier than problem number 6 in my mind. So what we do, remember you have those two numbers kind of like in an ordered pair with a comma in between. And we're comparing negative 10 and positive 6. That's what they tell us right here, negative 10 and positive 6. And we used a parentheses, remember up here. So we're going to use a parentheses here for the negative 10, and we used a bracket here, and we're done. I think those are very simple. Problem number 8. Okay, I actually talked to your teacher, Mrs. Roberts, about this problem. I wanted to know what the best way to teach this to you was in her mind, and she said that you guys get so confused, and not just you three specifically. I'm just saying that she said that normally her classes get so confused that this is how she teaches it. She said that you rewrite the inequality just as it is. Then you rewrite the inequality, but instead of using the same inequality sign, you flip it, and you have to do the opposite number. Okay? So now, we have negative 2m. So we're going to subtract 3 from both sides because we want to keep that negative 2 on that left side. So negative 2m is less than or equal to negative 1. This is where it gets tricky. We did learn this in 1.7, so this should be in your notes. Whenever you divide or multiply by a negative number, you're always going to have to flip that inequality sign. Always, always, always. Okay? Okay. Then the same thing over here. We're going to solve this. It gives us negative 2m is greater than or equal to negative 5. We're dividing by a negative, so that means we're going to have to flip that inequality sign. Okay. So now we had a 1/2 and a 5/2. Okay. I put 1/2 on this side because 1/2 is the smallest number. And then I put 5/2 over here because it is the larger number. And on a number line, the smaller numbers go here and the larger numbers go here. So notice you're always going to have them facing this less than pattern, okay? But notice they were both equal to, so they're both less than or equal to. And notice when you look at the m is greater than or equal to 1/2, the alligator mouth, as we always talk about it as, is facing the m. Well, notice when we switched it around, the alligator mouth is still facing that m, okay? So now we're going to graph it. All right, so I'm going to do 1/2, 2/2, which is 1, 3/2, 4/2, which is 2, and then 5/2. Hopefully y'all can see what pattern I'm using. I noticed that they both had a denominator of 2, so I just counted 1 to 5. 1, 2, 3, 4, 5. So it's saying that m is in between those two numbers. And they're both going to use brackets because they're both the equal to. If you're using the circles, then they would both be closed circles. And you shade in the middle. So for interval notation, you write your two numbers you're comparing. And since they both had brackets, you're going to use brackets on both of them. All right, problem number 9 says that we have the absolute value of 4 minus 2x is greater than 10. So remember, we're going to use our same inequality, and then we're going to flip the inequality sign and do the opposite for the second one. Okay? And remember, this happens in absolute values. So, here, 1 second, guys. All right, so we have to solve these for the x. So we're going to subtract 4x, or 4 from both sides to get negative 2x is greater than 10. Sorry guys, apparently I'm struggling right now. So to get this x by itself, subtract 4 from both sides to give us that negative 2x. Bring down your greater than sign. 10 minus 4 is 6. Divide both sides by negative 2 to get x is greater than negative 3. So now we're going to subtract 4 from both sides, which gives me negative 2x is less than negative 14, because negative 10 minus 4 is negative 14. And then divide both sides by negative 2 to get x is greater than 7. Hopefully you guys noticed that you were dividing by a negative sign. So when you divide by a negative, then that flips the inequality sign. So since we did that over here as well, our inequality sign should have flipped. Okay? So this is saying that x is less than negative 3 and x is greater than 7. Okay? So this one is a little bit trickier. So here, your graph would look like this. So x is less than negative 3. Okay, so negative 3 is here, and it's saying that x is smaller than negative 3. So we're going to shade to the left because that's where your smaller numbers are. And we're going to use our parentheses for that. Okay? Then it says that x is greater than 7. Well, here's 7. If x is larger than that, then you're going to shade to the right. And you use your parentheses because there was no equal sign under that. Okay? So sometimes this can happen. It's saying that either this or this is going to happen, or both of those sets of numbers are going to work. So you're going to have two separate interval notation sets. So over on this side where you have the -3, well, let's find out. What were our two numbers we were comparing? Well, on the right, -3 was the farthest right number that we were talking about in this set. And the farthest left is -infinity because it keeps going and going and going. Well, on the right we used a parentheses, and where we had -infinity we're also going to use a parentheses because remember, anytime you use an infinity we're going to use parentheses. Now on the right we're comparing two numbers. We're comparing a 7, which was the farthest left number, and this keeps going and going and going and going. So that gives me the infinity there, and it's a positive infinity. Notice that this is a negative infinity because it keeps going through all negative numbers. It's a positive infinity because it keeps going through all positive numbers. So the number on top of the 7 is going to be a parentheses, or the symbol we're going to use is the parentheses. And then since this is an infinity, we also use parentheses. All right, moving on to problem number 10. This one's very simple. They're just asking us to get the m by itself. That's all they want us to do. So the first thing I'm going to do is get rid of that 1/2. Okay. Well, the only way to get rid of a 1/2 is to multiply that whole thing by a 2. And remember, what you do to one side, you have to do to the other side. Okay. So that gives me 2k equals that 2 and that 1/2 cancel, because if you do 2 over 1 times 1 over 2, that's going to give you a 2 over 2, which is 1. So that's why those cancel, mv squared. And then to get the m by itself, well, m is being multiplied by that v squared, so the opposite would be to divide. So you should get 2k over v squared equals m. Okay, I really hope that this video has helped you guys out. Sorry that I stumbled a little bit on number 9. I struggled a little bit on that one, but I hope this has been helpful. If you have any questions, please do not hesitate to ask me any of those. Okay, all right, I wish you the best of luck.